Hello, my name is Justin, and today I will talk about Internet Protocol version 4, or simply IPv4, which was introduced in early 80s. This standard became so popular that it is still in use today. Internet Protocol are rules for routing or sending packets of data across networks between devices and allows us to connect to the World Wide Web. Therefore, Internet Protocol is important because the Internet would not exist without it. IPv4 comprises 32-bit numbers or 4 bytes separated by dots, which provides us up to 4.3 billion unique addresses. By the size and volume, addresses are identified in 5 classes. However, only class A, B, and C are the most common because class D and E are not generally used by end users. According to our needs and the size of our network, we can decide which class is suitable for us. But what if class B is too large and class C is too small? What I learned about IPv4 is that you can use subnetting to solve this network size problem. To create more efficient network naming schemes, we can choose the part of our IP address that we want to devote to the network and host IDs. Subnetting does this by allowing us to select a preferred number of bits to use for network ID. Some other topics that are related to Internet Protocol are IP routing, address resolution protocol, network address translation, domain name system, and Internet Protocol version 6. In the last years, this is what happened with IPv4. Due to rapid technological development, the quantity of internet users has increased and reaches over 4.6 billion today. IPv4 address exhaustion became a serious problem for internet expansion because IPv4 can't provide enough unique addresses. Therefore, in 1998, IPv6 was introduced to solve IPv4 address exhaustion problem. However, the adoption of IPv6 has been delayed due to network address translation problems. Lately, there were discussions to free up hundreds of millions of IPv4 addresses. The proposals were to unreserve 4 kinds of reserved IPv4 addresses, treating them as a global unicast space. The first proposal was to use the lowest IPv4 address on a subnet ending with a 0, which is reserved for a broadcast but not commonly in use, because most commonly we use the highest number on the subnet for a broadcast. The second proposal was to use a class E address space that was reserved for a future use as a global address space. The third proposal was to use the private addresses that were intended to use for auto configuration in 1981. However, the system that should use these addresses was deprecated in 1989. And the last proposal was to use reserved loopback addresses because it is not common for loopback addresses outside 125.0.0.0 with a mask 16 to be used at all. And this would provide us extra 65,000 addresses. People who understand IPv4 and how it works have network specialist or network engineer jobs and make from $50,000 to $120,000 per year salary, depending on the job complexity. So if you understand Internet Protocol very well, you can get a really good job with a decent pay rate. Thanks for watching.